Welcome to this Connect with BMC Helix, ITSM, and Remedy webinar. This presentation is on OnPrem Remedy Architecture Platform Deployment Simplification Case Study. In today's topic, Darius Wallace will take us through this content. Over to you, Darius.
Thanks, Greg. This session, I want to be very clear, this session and the content that we cover here is actually a complement to a previous session that was presented back in June that was titled Optimizing the Remedy Platform Solution. So this session is intended to apply the concepts that were introduced there and give a case study and show two examples where those principles were applied in the real world and see how the trade-offs are made, coming back to some of the key points that were called out in that previous presentation. So with that in mind, let's go ahead and step through how we're going to discuss and look at some of the items that we're going to cover in this deck. First, we're going to do a little bit of a background, do a level set, cover some things of the platform and the architecture in general, and cover some of those basic elements and why it's led us to making sure we introduce some clarification about the architecture and the opportunity for efficiency in the architecture of the environment. And then we'll look at two case studies. Each of them apply these principles in slightly different ways, but the philosophy still holds. And then we'll close out with references so that you can spend some time looking at other examples that were used to support the material we're going to cover here. Okay, with all that being said, let's jump right into the background. The key thing to note here is, from the very beginning, the Remedy architecture was always based upon looking at three layers: the UI layer, server layer, and the database layer. For those of you who go back in the early days of Remedy, UI layer, you'll recall the thick client that we had for the user tool. Eventually, there was an introduction of mid-tier. We had the admin tool, which then became Dev Studio, etc. These are the things that are working on that front end of the interaction with the end user. Then there's the server layer. There was always that the servers that would be the workhorse for processing filters and activities on the back end. And then you have the database layer. Well, over time, as we evolve the solution, as new opportunities present themselves to be more effective and efficient in the service management space, certain elements of the architecture get introduced, especially for supporting large enterprise customers. You have an improvement in the front end with Smart IT. You have RSO dealing with providing Remedy SSO as far as authentication and supporting a generic way in which people can get in the system, introduction of a component of MongoDB, smart reporting, etc. There's a variety of components that came into play as the solutions that has evolved over time. Now, here's the catch. At some point along the way, we started noticing that there was a misinterpretation or an assumption that with these different components, they each needed their own infrastructure or hardware to support them. And as a result of that, we started noticing out at customer sites that things started turning out to be the sprawl of hardware that would come into play. And what we're looking to do here is to get back to the basic and the principles. The architecture has always been considering these different layers and supporting the ability to scale horizontally, not necessarily trying to set up a different piece of infrastructure or hardware for each component that comes into play. Now, there may have been instances that have led for the need of that, but that was not the intent or the design. And if that came into play, we took steps to try and correct that so we stay within this model. So let's look at how some of those principles come into play and how some of the adjustments that have been done by customers who ended up in the sprawl situation and then moved their way back to a more consolidated representation and making decisions based upon this model. So let's go back to the basics. We have the UI layer, the server layer, and the database layer. Now, I'm going to give you a reference at the end of this deck that takes you to documentation that illustrates that there is a client layer, web tier, server tier, and a data tier. And the only thing we're trying to illustrate here is that there's different aspects or different layers that you would interact at. There's the client tier, whether it's your mobile client, your laptop, desktop, things that are coming into the system. At the web tier, it's important to note, we're not trying to talk about the number of servers that are involved here. We're just talking about the different types of functions or capabilities that would be represented at this layer. and then you have your server layer and your database layer. So just to tie it back to our starting point, the UI layer in the current model of how we look at things is broken up into two tiers, the client tier and the web tier. For this discussion, we're looking at infrastructure and the back-end components of the architecture of the environment. So we're going to be focused primarily on the web tier, server tier, and the data tier. Okay? So with that in mind, let's take a look at our first case study. In this situation, the customer was experiencing a couple of issues. They were having intermittent performance issues, and they were dealing with not only the current operational overhead, but continuing along the path that they were on. It was somewhat daunting to consider the amount of overhead that would be in place, operational overhead that would be in place if they kept expanding the environment in a way that was based upon function associated with server that led them to the current sprawl that they have. But if they kept on this path, they would still be in that position where they have even more sprawl, which would lead to even more overhead. When it comes to the intermittent performance issue, you're going to find that throughout time. But the problem is when it occurs and you have sprawl, it's very difficult to triangulate on where the performance issue is. You got logs on different servers. You got different things that are laid out with different configurations at the OS level. And that leads to difficulties in isolating where the performance issues are occurring at. So from that, they have a couple of goals. Standardize on the hardware, consolidate the hardware in the process. So as they have this different hardware and they want to bring things together and they decide to co-locate certain functions, they want to consolidate that hardware and get some benefit from that. And as a result of that, make sure they're in a good position to deal with some of the issues they have addressed from before. Some of the key trigger points for them to take on this initiative was, first and foremost, in this situation, the current situation, they were looking ahead and acknowledging we can't keep doing this going forward. Because with the staff we have now, this is overwhelming. If we keep on this path or this trajectory of setting up boxes per function, and we know we have several other things we want to do, it's going to go beyond what our capacity is to keep all this stuff up to date. And one of the primary goals of these three was to standardize on their hardware and their blueprint for how they would be able to scale horizontally. So let's take a look at what their starting point was. What you'll see is at the web tier, they had initially combined Smart IT and My IT. Then they set up the functions that were supporting the integration capabilities they were looking at. They had started some work on working with Service Broker, and they set up a separate box for RSSO. Now, you'll see over here to the right that their total count of servers at that layer were 6. The server tier had 2, and they started off with the database tier of just 1. So a total of 9 servers. So even in this scope, even with this configuration, they became aware that there are several other things they wanted to introduce down the line, and this would result in adding more and more boxes. So they took a step back and started looking at where is the opportunity for them to collapse things, especially when we started talking to them about how capability can be co-located on the same box. And do that in a meaningful way, do it with purpose, and understand what your utilization is going to be so that you understand what are the right things that would be co-located. And once they scale beyond a certain point, when does it make sense to spawn those things off with their own separate set of resources? So that was all taken into account when they took a look at this. And they drew the conclusion that in these key areas with regard to RSSO and the Service Broker standing on their own, there was an opportunity to consolidate those and have those co-located with other functions. In addition to that, with some degree of assessment, they realized that their integrations didn't actually take up as much resources as they initially thought. Because they were focused on the function and making sure they had enough hardware for that function, in this case integrations, they wanted to oversize and plan for the future, as opposed to understanding or the opportunity for the other functions to be co-located with the function of integration. So when they took a step back and looked at the performance and the amount of information that was flowing through their integration channels, they realized that they may have over-allocated initially. And if they did this in such a way that they could scale horizontally, they'd be in a position to easily expand as needed as their integration load increased. So in that regard, they were looking at the opportunity to reduce the number of servers that would support that function. Now, these just didn't go away. They just didn't drop these servers out of the mix. Let's take a look at how things came together. What happened is they took the integration and the mid-tier capability, and they kind of set that aside for the moment. But what they wanted to do was establish a base that would act as the blueprint for supporting their horizontal scaling. And that base was made up of mid-tier, Smart IT, and My IT. Right? Now, with that base definition in place for their server, they then looked to move RSSO onto that server and co-locate it with the function of these servers. So mid-tier, Smart IT, My IT are running on both of these servers. Right? And then those servers and that functions that go through that channel go through the load balancer, hit the backend, and then ultimately hit the database. Right? Now, when they want to scale horizontally, they take their base. It has Smart IT, My IT, and the mid-tier available. It doesn't necessarily mean that all these functions are enabled, but their base template or their base footprint would be this configuration you see here. And then you'll note that they then used the opportunity to put the service broker to co-locate it on this other instance of their base. Now, at the time of this review, this was the end game for what they needed to accomplish. And you'll see that the number of servers they started with went from 9 down to 6. And mainly it was consolidation at the web tier. Now, over time, when they look to expand and now add other functions, the equation is different. The way they approach it is different. They would look at their web tier, if that's where the capability fit, and they would take their base of Smart IT, My IT as their base template, and they would put another instance out there for that and enable it as necessary. So, for example, if they found that the throughput that they needed for My IT increased beyond the capacity they had right in place right now, they would look at adding another base instance. And they would likely disable the Smart IT component and dedicate the throughput for the My IT functionality. But to stand up that other server with a consistent, reliable way was key for them. When they look across these servers and try and understand what the footprint looks like, there's consistency at that layer as they look at trying to address performance issues. So this is how the principles were applied in a very straightforward manner for a customer. The important thing to note here is that this is not a formula to then go back and say, oh, let's do the same thing. What we're trying to share here is that the idea that you have these layers and looking at things to be able to scale horizontally is a much more effective approach to manage your operational overhead than to have sprawl and setting up these independent boxes based upon function. So that's where it leaves us with regard to this particular case study.
There's a question. Was there a reason why RSSO was on a separate server in the initial layout?
Yeah. So this goes back to a point that I made earlier, where there was a necessity to do that before. At the time that RSSO came out, for that particular release, there was something going on in RSSO where there was a port conflict with one of the other applications. So to be able to put RSSO and co-locate it on with other applications was not really an option because of the conflict with the port. That doesn't mean that therefore the answer is to say now RSSO needs to stay on a different server. What that led to is, no, the principle still holds. We needed to fix the software, what we had done in RSSO so that it could in fact work the way that we've described here, right? So again, one other subtle point I want to make here, just so that the images don't lead people to some confusion. We're not talking about that when you have multiples of these things on the same box. They may all have their own web server instance, right? We're just talking about the boxes that are involved that these items would run on, but they may, on that box, they may all have their own separate web service instances based upon what makes sense, right? So it's a bit of clarity there. And if you want to understand more about that, again, I again refer you to the session that was presented back in June titled Optimizing the Remedy Platform Solution. All right. So now, if we take this as a kind of a simple example, let's go to case study B. With case study B, what we're going to do is look at a more involved solution. And let's start off by understanding what the starting point was for this particular customer. Well, again, there were some intermittent performance issues. Again, this customer started off in a sprawl, had a variety of things put out. They were standing up servers based upon function, and you end up in a situation where you have things in different different servers inconsistently in how inconsistent in how they're deployed. And when you have a performance issue, it's a challenge sometimes to isolate and triangulate on those issues. There were some issues going on with the stability of FFTS and how information was flowing through the system and trying to isolate on where that failure point was. There were some challenges going on with the load balancers and ending up with uneven distribution of information that was flowing to the back end. So infrastructure again was challenging for them to make sure that they had items flowing and getting well distributed across the back end servers, or what was acting as the back end servers. And with all of this going on, largely tied to how things were deployed in the environment, the operational overhead was just beyond a point that they were willing to live with going forward. So they established some very clear goals. Gradually move one of their guidance, one of their directions that they had planned for is they want to gradually move their online users to Smart IT from the mid-tier. Mid-tier is where they started. They've been on the Remedy platform for a while. And with the release of Smart IT, they were gradually moving their service desk agents over to that Smart IT interface. So that was a gradual move with the expectation that mid-tier would then be limited to supporting either admin activities or to support integration activities. They wanted to standardize on the hardware. In the previous environment, there was different configurations for hardware. Some had different footprint for CPU versus memory, and that made it difficult for them to understand whether or not each of the servers had the sufficient capacity to support the activities that it was dedicated to. I also wanted to consolidate the amount of hardware footprint they were using. And of course, with all of this activity, they wanted to address the issues that they were seeing in performance and make sure that if they had performance issues, they could more easily triangulate on it. There was definitely an opportunity to address the issues with FTS by increasing the resource availability for the type of volume that was going through the system. All right. So let's start off by taking a look at what their starting configuration was. So a lot of information coming up. Let's just walk through this a little bit. I'm going to start on the right-hand side and call out each of the sections here, right? So we have the web tier, the server tier, and the data tier. The web tier had a set of boxes that were acting as the front end for Smart IT and My IT. They had a front end component for Smart Reporting. They had some dedicated servers for the integration activities. They also had a separate set of servers that were limited to just doing admin functions in the environment. And once again, they had a situation for having RSSO off on its own space. Now, in this case, they used two servers because they wanted to support the failover of having RSO as a primary and a secondary. Now, again, the consideration is that if you look at this, you basically have servers that are aligned to functions. And if you come back and start looking at additional functions coming in, you then end up with more servers. Now, we cannot overlook the fact that when you start consolidating functionality into a common footprint, that you're going to keep the same number of resources unless you're underutilizing the footprint you had before. So this was very well understood as this customer was looking at the fact that, yes, we are going to consolidate where it makes sense. But we're also not going to shortchange what needs to be done in order to make sure that the resources fit the need in memory and especially in CPU. So with that in mind, let's take a look and make sure that we take those considerations into place. Again, please understand this as a case study. This is what this customer was looking at in order to have sufficient CPUs in place to support what they needed at the time. So they started off with 24 CPUs, 96 gig of memory to support the function of IIT, etc. You can look through all the different resource allocations that were set for each of these functions. So when you start combining things, you want to make sure that you have enough resources to support the combined function that's now being served by that infrastructure. So to that end, they started looking at opportunity for consolidation. You'll see that we'll start off with some pretty straightforward areas. As we mentioned before, RSSO was an area that was an opportunity for consolidation, as well as this function that they had set up for the admin going through the mid-tier. They had 3 servers that were set up there in order to support basic admin functions. And they've since clearly established that they don't need that many servers to support that particular function. And with that in mind, you'll see that there was a consolidation where RSSO was moved to a common area with the smart reporting function. And you'll see that the admin function was collapsed and combined with the resource allocation set up for the front end for integrations. If we go a step further, they realized that after monitoring and paying attention to the current capacity for their integration, they didn't really need the 3 servers up front, especially if they invest in a bit more resources. They could reduce the footprint of the number of servers and increase the resource of the servers that were remaining. We'll see that in a minute. You'll notice that on the right-hand side, those 2 servers that were going in a dedicated fashion, these back-end servers are no longer needed. And it was also determined that the number of back-end servers to support the functions of the integrations and the admin functions did not necessarily require 4 CPUs. So as we move forward, they also took a look at RSSO and the combined with the smart reporting, and this was a little bit more of a shift in direction in their use of smart reporting. They got very good at understanding how smart reporting was actually going to be leveraged within the solution, within their environment. And it turns out to be a little bit more focused than they initially anticipated. So they were able to scale back a little bit on the resource needs of the smart reporting function. So when you take that all into account, you'll notice that the changes that occurred with regard to the amount of memory has increased because we've consolidated capability into the footprint that is now serving combined functions. So you'll notice on the left-hand side, they started working with and looking at DWP Advanced, working in conjunction with Smart IT. Let me start here with a very clear example. This is an example where the customer made a decision because the DWP Advanced was an early initiative that was going to be set up for a targeted audience on a relatively small scale while they came up to speed on how they were going to support their catalog and their self-service capability. This wasn't a deployment for the entire enterprise. At the moment, it was sufficient for that to be co-located with their capability for Smart IT, which was their primary interface for a majority of the users that were using the system. Now, as time goes on, and they establish that their self-service capability is going to now start tying into a broader audience, they may make a different decision and look at whether it's worthwhile to split out and have the DWP function serve on its own at that web tier. But in the very beginning, the footprint for the resource footprint that's put in place would readily and easily support the volume or the audience that was going to be leveraging both DWP Advanced and Smart IT. Okay. So similar decisions were made in other areas as well. And the net of this was a reduction of 11 servers. They went from 27 down to 16. Now, the size of the servers are larger because of the memory and the CPUs that are allocated for them. But as far as establishing a standard for what their footprint is, having a consistency across these different servers was very key in their decision process for this new proposed architecture.
Darius, a question. What was the base template for case study B? As case study A, we saw the template was mid-tier Smart IT and My IT.
Right. So, yeah. So, good question. In the first case study, the customer was really more focused at the application level and being able to expand horizontally with a consistent application footprint, and they would enable and disable the function as they needed as they expanded that footprint. However, with this customer, their issues were more in the area of the inconsistency in the hardware. In this web tier layer, every server here has 8 CPUs and 128 gig of memory. And so their goal for their footprint was that configuration for the most part, as well as the storage capacity. So that was their footprint. Less about the app layer and more about the consistency in the hardware. At the server tier, they were making a slightly different decision of allowing those CPUs to have 12 CPUs with 128 gig of memory. Right. So their targeted goal was really at the OS and the resource layer to introduce consistency at that level. Where they were before is they had some servers with 8, some servers with 4, different 30, some had 32 gig of memory. And so when it came to trying to understand where the performance bottleneck was, with this proliferation of different servers having different capacity, it made it very difficult for them to isolate and ensure that they got a consistent throughput of activity. So they were more centered around at the hardware level and the operating system level, ensuring that there was a consistent footprint that they would use to support each of the different tiers that are at play here.
I have one more question that's here. So how long does this consolidation take?
Okay. The short answer to that is it depends. There are a variety of things that come into play about going on this journey and trying to make sure that this is done in such a way that allows you to get to your end game and to satisfy some of those goals that we stated up front. How long it takes largely depends upon what your initial sprawl situation is, how effective and efficient the organization is in being able to make these kinds of adjustments. And at the same time, sometimes when you make these adjustments, you have to do so, especially if you're focused on the hardware, you want to do it so that it's transparent to the end users. So if you have a very diverse and sprawl throughout your infrastructure and you're trying to recover and get into a more structured approach that we're talking about here, it could take a while. I mean, I can't give you numbers or days because it varies. But I think once you lay this out and you start looking at what your target or your end game is based on where you're starting, it's not difficult to put together a plan. It could be as, something that's the actual execution is done over a weekend because you're making the changes to the hardware. But the time and the planning may take several weeks or a couple of months for you to plan and make sure you have everything. And then heaven forbid you have to deal with making decisions about how long it takes for you to get the hardware, the provisioning of the infrastructure to make this happen. So I don't have a definitive answer there. I can say that most customers try and do this kind of update within their maintenance window when they're focused on the hardware level. It's a different story when you also start mixing in upgrading the hardware to get to this level of resources we're talking about, and at the same time talk about upgrading the software on top of that. And we'll talk about that in a minute as well. Okay? So let's look at the key considerations and takeaways to kind of bring things all together. This first bullet kind of replays what I said before when I was answering the previous question. Please be sure not to confuse a software upgrade with a hardware upgrade. I am not trying to suggest that these aren't two things that cannot be done in conjunction. What I'm trying to emphasize is that these are, in fact, two initiatives. And you have to be very clear about what you're going to do when you do your upgrade of your software and your execution path for when you do your hardware. There have been instances where customers have tried to combine that into one operation. And it introduces a degree of complexity that becomes daunting and is fraught with risk. What you want to be able to do is assess what it's going to mean to do an upgrade of your software, and in fact, in some cases, what components of software that you're going to be upgrading. And then take a look at what you're going to be doing with regard to upgrading your hardware. And that will lead you to some very key decisions. Once you understand each of those things, then you can start coordinating when you do these operations with the intent of minimizing the impact to your end users. All right? So the key takeaway here is you may be planning to do or need to do both of these, but please look at both of them through separate lenses and then figure out how you can coordinate both those activities. Sometimes it may be serially, or sometimes you can be more strategic if you have the right maturity within your organization to do this in a combined fashion. But first, take a look at them as separate initiatives. It's important to also keep in mind, do not shortchange the importance of the people process of the equation. When looking at these hardware upgrades, you want to make sure that as you do these types of operations, there is a change process that you shouldn't be circumventing, right? There should be a plan that's put in place around this. What I'm saying is relatively obvious, but it's surprising that once folks figure out that, oh, you know what, I'm going to put in a better and a faster piece of hardware in order to address my performance issue, and they try and put that in place, that they don't take into consideration the governance that needs to go around, not only putting that in place, but also doing it in such a way that minimizes the impact to the end user community. The brute force will get it in there right away. There may be an outage window accordingly, but especially if you're doing things at the server level, at the server tier, with zero downtime, there's an opportunity to do things in a strategic manner that basically has little to no impact on the end user, especially when you're focused on hardware. When you're dealing with software, obviously there's a people process element. You have to make sure you're communicating to all the principals what's going on in the environment. Again, that should be all wrapped into your change process. So just as you look at this, take the time to wrap around the people process side of it, especially when you consider the activities that you're going to do on the back end once the system is up and running. You need to know your baseline before, how you're performing, what you have in configuration. Look at the pictures that we showed before to make sure that you know what your after looks like, of course, before you execute against it. This also leads you into another area of discussion. How should I go about this? Let me be very clear about the following statement. Neither of these are right and neither of these are wrong. An in-place upgrade is a good fit for certain circumstances, and a staged upgrade is a good fit for other circumstances. So the key is to pay attention to what the scenario fits, what approach you're going to take. Let's just focus strictly upon hardware. In looking at the hardware, there may be the ability, especially if you're going to be swapping out servers at the server tier, that you're simply adding infrastructure or adding additional capacity into the server pool or the server tier, and then ultimately deprecating a server that is one that comes off the line or out of the infrastructure. That's when you're replacing a particular piece of hardware. It could be, in fact, that you go into a set of hardware and you just add more memory or you add more CPUs to that hardware because you have the capacity to do so. But with hardware, there's also another consideration. I've seen in several instances that customers decide that, you know what, I've been running on this hardware for a period of time. We've patched it over the last, 4 or 5 years. You know what, we have a new standard image for what our hardware footprint is going to be. And I want to make sure I get on that, and I want a clean start. And in that case, they make a choice to stand up a standard image of the hardware. They could have just added more memory. But because of the binaries or the DLLs or the things that are at the operating system level of that hardware, they choose just to say, I want a new clean set of hardware, and what I will go in and do and apply my software and move it over to that hardware accordingly. Right? So that influences whether or not you're doing a staged or an upgrade. When you're looking at software upgrade and hardware upgrade as a combined thing that you're trying to do, there are definite benefits for considering a staged approach. Because with the staged approach, you're able to set up the new hardware, get your software installed over there, and then you're dealing with migrating your information over into that new environment. Okay, once you've done the upgrade accordingly. The trade-off here is that you've got a cost footprint that you have to put in place. But what it does do by having that staged environment is it allows you to minimize the impact to the end user. Because with this other infrastructure, the staged environment, you're able to have things up and running and excuse me, up and running, tested, hardened, and essentially flip a switch to get over to the new setup. Now, again, please don't take that to mean that therefore the staged is the best way to do this. There's absolutely equal viability for doing an in-place upgrade. You just have to plan for that because doing in-place has its own benefits, especially again when you're doing with things that you're talking about at the server tier and you're dealing with software there, right? So the key here is not to emphasize one or the other. The key is understand that there are two options there. Consider both, put together your plans around both, and pick the one that best serves your needs in your environment for your end users. And finally, oftentimes we get to a point where we get to that end game and then we just start running forward. As pointed out before, once you put this resource or this infrastructure in place, you always want to continue going down this path of proactively monitoring and establishing a new baseline for your performance for the key functions that you're working with in the environment. And you want to continuously look at that performance component because this puts you in the position of being able to expand your resource pool for the functions that you need to get ahead of eventual performance issues that may come on board because your audience expands accordingly. But with this structure, with this approach, again, it gets back to the benefit of scaling horizontally and taking advantage of some of those concepts we talked about, having a base image. You stamp that out, enable that capability, disable the functions that are relevant, enable the ones that are appropriate for what you're trying to do, but you got a consistent method for standing up and expanding horizontally accordingly. So, again, I've said it before, I'll say it again. Hopefully after this, you kind of see that this is an indication of how you apply some of the key concepts that were presented in the session that was done back in June for the session titled Optimizing the Remedy Platform Solution. And for those who are looking to take some time to go back and review that material or maybe see it for the first time, I've included a link here where you can pull that up. And then there's also documentation online and available that also captures these principles. So please take the time to leverage this material. Hopefully you found this helpful. And let us know. Looking forward to your feedback and comments. Greg?
Now I will take us through the closing, some self-help and contacting BMC. Our videos as well as this webinar recording are available via our YouTube channel. Once this information is posted, it is reflected in our Connect with BMC, Helix, ITSM, and Remedy schedule, available at this communities link, as well as the product support pages that contain different videos, documentation, knowledge articles, combined based on product component. A very useful resource available 24/7. And as always, our technical support methods of contact via web, phone, and email, as well as the social channels as well. Thank you.